For number 3, we're translating these definitions from the preface to the student into quantified sentences, and I've copied the preface to the student over here so that we can see. So for A, we have that the integer x is even. Now from the preface, we can see that it's even if and only if there's an integer such that x is equal to 2k. So if it is even, that means that there exists an integer k. So there exists a k belonging to the set of integers such that x is equal to 2k. For B, we have that the integer x is odd if and only if there is an integer, so there exists an integer j, so it exists a j belonging to the integers such that x is equal to 2j plus 1, okay? For C, we have that the integer a divides the integer b. So if we have this, we know that if and only if there is an integer k such that b is equal to ak. So if a divides b, then it means that there exists a k belonging to the set of integers such that b is equal to ak. Now for D, we have a natural number p is prime. So it's telling us that the natural number n is prime, right? So we have that the natural number p is prime if and only if p is greater than 1. So we're going to say that n is greater than 1, right? And the only natural numbers that divide p and 1 are p. And so we're going to say for all the natural numbers, so for all m belonging to the set of natural numbers, if m divides n, then that must mean that either m is equal to 1, right? Either m is itself, either equal to 1 or m is itself. So either m is equal to 1, or we have that m is equal to n. So basically what we're saying here is that for a natural number greater than 1, if any other number divides it, then that means that the number is either 1 or is equal to itself, right? That's the only way for it to be prime. Now let's look at it when we have that it's composite, right? We have a composite is a natural number that is neither 1 nor prime. So for this one, we're going to say n is not equal to 1, right? And let's see what we have. And it is not prime. And so for it to be not prime, we're going to negate. We're going to negate, we're going to negate the stuff over here. So for us to negate it, remember that when we're negating a universal, we're using the existential, right? So we're saying, and there exists an m belonging to n, right? Such that m divides n, and because remember that when we're negating a conditional, we're saying p and not q, right? So we're saying and not q is we have here m does not equal to 1 and m does not equal to n, right? Because we just negated the conditional. So let me close this bracket. Yep. So that is what we're saying, right? We're saying that there exists a natural number such that m divides n and m is not equal to 1 and m is not equal to n. And that is it for our translations.